Okay, Adrian, do you see my presentation?
Yes.
Yes. All right. So welcome everybody. Good morning, good afternoon, good evening, wherever you are. Welcome on our new webinar. Today we are going to have a presentation, like a webinar, about the optimizing inspection, enhancing asset integrity and efficient maintenance, removable passive fire protection, Benarx Epoxy Panels for the steel structure applications. Yes, so yeah, a couple of words about ourselves. So maybe I will start first. So my name is Damian Kumorkiewicz. I'm a global technical sales manager for Benarx Epoxy products globally. I've studied oil and gas engineering and one of university in Poland. I've been working for Berenberg for the last over 7 years, and I'm in the oil and gas business for more than 10 years. And today we have also our second distinguished presenter, Adrian Hillstan Halland. So please, Adrian, feel free to say a couple of words about yourself.
Thank you, Damien. My name is Adrian Holland. I'm engineering and R&D manager for Benarx Epoxy product series. I have a master's in civil engineering and material science from university in Norway. And I've been working together with Berenberg and in Berenberg for in total 10 years now.
All right. So before we start talking about the removable PFP, Benarx Epoxy Panels, we would like to just highlight why we fireproof the steel structure. So in general, fireproofing plays a critical role in a protective structural element, fire barriers and process and safety equipment during the emergency situations. It ensures the PFP applied on these components remains functional, buying the time for safe evacuations. When designing a fireproofing system, we must consider of course, fire ratings, like what type of the fire duration, the standard you need to follow, what's the critical core temperature. We must also consider durability against the weather, UV exposure, sun. If you have cryogenic conditions, you have to take into account what about the resistance for the corrosions, which is one of the main problem in the oil and gas industry. Factors like weight, installation speed, and cost effectiveness are also key critical factors. On the right bottom pictures, here you have the structure where right section of the structure supports have been fireproofed and are still intact, while the left side of the structure hasn't been applied with any PFP system and it failed. And this difference, it's purely visible. So failing to implement the proper fireproofing can lead to the severe consequences, like a potential loss of the life, process infrastructure damaged, environmental harm, and possibly stricter regulator expectations, and of course reputation damaged. So our responsibility as a removable PFP suppliers, among other PFP suppliers, is to design robust and durable system that safeguard both people and assets. So we would like to just briefly mention how relevant structure are defined for the PFP. So during the risk assessment, fire risk assessment, which is normally performed by a technical safety or process safety or HSE engineering departments, representative scenarios are selected through initial fire risk analysis. This process evaluates leak frequencies, ignition probabilities, inventories to identify the cases with the highest risk areas. So the goal is to determine the fire loads and design accidental loads, which guide fire protections measures. Alternative way is to follow the API 22 guideline, which is a fully open source document. If you like, you can Google it and you can study this document. Here you have a very short video showing the simulation of the gas explosion with a fire on one of the onshore facilities. And on the picture at the right, when technical safety did the fire risk analysis, then based on that, the PFP scheme has been identified where to apply the passive fire protection for the critical steel structure members. Of course, where CSP, which is cryogenic cold spill protection, and PFPs are applied in these facilities. So, for example, in refineries or petrochemical facilities, they protect the structures like distillation columns, cracking units, reformers, hydrocrackers, cooling towers, tank farms. Often PFP is also applied for a gas treatment and gas processing facilities, which are very often exposed for a jet fire demand. When it comes to the offshore facilities like FPSO, FLNG offshore platforms, we often apply the PFP for processing modules, for a main pipe rack, for example, or for liquefaction modules when it comes to FLNG units or transfer and loading modules. Also, you have a quite hot topic with the projects when it comes to LNG liquefaction project especially. So very often liquefaction units, refrigeration system and storage loading tanks are fireproofed with a main structure over there. So passive fire protection on the steel structures relies on the several traditional methods when it comes to the PFP. You have several methods. Each has a unique characteristics. So first, dense concrete PFP, it protects the structure by releasing water vapor through endothermic reaction. Lightweight cementitious PFP works in similar. However, it's lighter and easier for application. Both dense concrete PFP and lightweight cementitious are wet applied. In late 80s, epoxy tumescent coatings arrived to the market, when in contact with a fire, it expands, creating insulation char around the object, metallic substrate, which protects against the fire. And the last solutions, we see this especially for a PFP of under the deck on the offshore platforms. It's ceramic fiber-based fire insulation. This is the board. It's static, not reactive, and it's very effective to protect the metallic substrate up against the very high temperatures. So yeah, these methods are tailor-made to the different fire scenarios and structural needs. So of course, when it comes to the PFP on the steel structure, the devil is in the details as always. Industry experience and insight from a PFP Net, which is the third-party non-profit organizations, highlight critical areas, attention to the project to ensure about the PFP effectiveness. So for a lightweight cementitious and concrete PFP, the project should pay attention to the hollow fill box details, corner birds, and application over the thermal spray aluminum. While for intumescent coatings, the project should pay attention to the side welded areas, application over TSA, and heat bleeding through open insulation joints. Across all the system, proper workmanship, quality control, addressing damages during the transportation or maintenance are key to consider too. interfaces between two different PFP systems, termination details, prevention of the standing water, corrosion must be handled carefully to maintain the integrity. So by prioritizing by the project these details, they can ensure about the reliable and durable fire protection on the critical assets. Yeah, the causes of the damage conventional PFP. If you work in the PFP industry or insulation industry, either on the EPC in the EPC side or directly on the facilities, you most probably witness a lot of damage PFP on the structure over the years. If you Google it a little bit properly, you can find much more pictures showing this as an industry evidence. The failed PFP system often is results from severe factors. These include incorrect specification for environment, improper installation, not following the manufacturer guidelines, poor detailing practices, which introduced and lead to the defects, basically. Over the time, of course, the system naturally degrades due to the UV, sun, rain, snow exposure, wind as well, and might also sustain the physical damage through normal process operations. Issue can also arise when PFP is removed and not replaced properly. We've seen a couple of cases like this in the past, or when repairs are done incorrectly, which basically introduce the new weaknesses. We see also lack of the proper maintenance, like a top coat, but for example, polyurethane top coat, it's not maintained in the right conditions. So addressing these factors is critical to ensure the PFP system remain intact and reliable. So yeah, a few pictures from the facilities. We have much more, but we would like just highlight this to you. This is for concrete PFP after where they fail on the steel structure. Water, of course, water ingress is of course one of the main faults. Reinforced mesh, which most probably is corroded on the most of the photos. It's also another issue. Not suitable top coats for the harsh environment. We also see this many cases. This occurs a lot of with the system which they've been used in the late 70s or 80s before epoxy intumescent arrived on the market. When it comes to the disbonding for concrete PFP, it's clear the steel substrate is corroding. So basically, this can be the number of the things. Poorly applied paint system under the fireproofing in a combination with a not suitable top coat, which is one of the major costs. Then lightweight cementitious PFP. Then we also see this a lot of cases when we did our project in the past, when we repaired the damaged PFP. It's not the goal for this webinar to talk why this low weight or concrete PFP failed. It's completely separate topic for the new webinar. However, since we highlight these photos, cementitious PFP have been coated normally in many layers, so it seems they haven't been complied with overcoating intervals. Last slide about the issue with wet apply PFP systems. So this is the example of failed intumescent PFP. In our opinion, that's the best wet applied PFP material available on the market, very well and tested and certified by third-party classification societies. It offers a lot of advantages. However, we also see in the inspection report that when we receive from the end users, due to some reasons, this intumescent epoxy PFP has failed. And here you have example when epoxy disbonded epoxy PFP being washed away from epoxy material, cracking of epoxy PFP due to the thermal expansion, poor detailing interfaces, and blistering. Major hazard for ignoring damaged PFP. In general, it possesses significant hazards. Falling debris, that's one of the major hazards that can happen to your facility personnel. That can injure your personnel, that can damage the equipment, process equipment, vehicles, and that's creating really high HSE risk. Another aspect are environmental hazard and not compliance with regulatory requirements. And in the combination of those factors that can lead to unexpected shutdowns and legal financial losses, and of course legal liabilities in the worst case scenarios. Damaged PFP also compromised with explosion containment, increased exposure to corrosion under insulation, not under fireproofing, and can delay the evacuation delays. It's risk that the equipment will lose own functionality and the structure itself. They might reduce the structural integrity. In the worst case scenario, that may lead to the structural collapse, which further enabling the spread of the fire to the connecting areas. So before we start talk about our system, which is the Benarx Epoxy Panel, we would like to just give you the message that when applied PFP, it's the best system to be utilized for the PFP of the steel structure, since this is the slimmest PFP thickness, very well tested, certified, used for the decades with many track records, both offshore and onshore, and provides unique characteristic. Yes, they failed in many facilities, but there are also some of the reasons. So what I would say, if we get any requests from the projects, that's a very that's a pretty more or less small section of the market when it comes to the PFP application for the steel structures. However, we would like to show you our case studies from previous projects and a little bit give you better insight about our system. So this is Benarx Epoxy Panel. It's made from a perforated stainless steel plate, stainless steel 316, which is acid-proof, and it's covered with epoxy intumescent coating both outside and inside. We applied also the epoxy primer and polyurethane top coat on top of that. So our standard color, it's white, but we can paint it at any color. The thickness range for this panel is depending on the PFP rating, but it varies from 8 up to 14 millimeters for the toughest PFP specifications. Weight also, it depends on the PFP thickness. However, for the 8 millimeter panel, the weight will be nearby 12 kilograms per square meter. The service temperature is up to 120 Celsius. However, if you have a higher service temperature, we can line up inside of the panel with one layer of, for example, aerogel blankets inside to protect the epoxy from expansion. Applicability for this panel on the steel structure, it's full range for 4-sided, 3-sided, 2-sided, 1-sided PFP for all scenarios. And we have many different fixing techniques like pop rivets, locks, bending, Hilti stud bolts, tensioning profiles, or we can combine both of them. We call it hybrid or duplex methods. How our panel works. So basically it works in the same manner how epoxy intumescent coating wet applied works on the metallic substrate. When in contact with a fire, it will start swelling and expanding up to 6-7 times the original dry thickness. And creating this black insulation char around the metallic substrate to protect up against the hydrocarbon fire. So when it comes to the details for the product configuration, we have several accessories. Not all of them are mandatory. So, for example, you have a Teflon spacer. This is the spacer between the metallic substrate and the panel itself for supporting functions. You have an air gap that creates small space for the Shartek expansion in our panel system, and also that gives you the very good ventilation functions. In case of the water ingress, the water will not be stuck there, and it's a very good actually to me solutions to mitigate the CUI. Watershed, so that's the roof principle on the top section of the panel, just to let water run off. Each panel segment is equipped with an identification plate or tag plate. We can design optional inspection hatches, so the project might have access to the relevant components or to check what's the sea corrosion conditions of the metallic substrate or check what's the water accumulations. Then you have fire rate and drain plugs, which drain water out from the system, and you have a weather protection silicone-based sealant just to prevent the water ingress, and some small minor gaps between the panel and metallic substrate. We fulfill this with an intumescent tape. In case of the fire, it works in the same manner how epoxy intumescent coating works, but this is only for a small gaps. Short overview of our fabrication process. So this is the pictures from our factory. First, we start for fabrication our panels. So our more or less standard leg, it's a 1 meter. Then we apply epoxy intumescent coating according to relevant fire specification, as smooth as possible through manual application. Then it's coated with a epoxy prime and polyurethane top coat, and coated also with a relevant color as project's color specification. Then it is equipped with relevant fixing methods. For large panels, for complex jobs, we might also do some pre-assembled works in the factory just to make sure that all fits together nicely. And of course, then it's packed and shipped to the project. Here you have an example of the various fixing techniques from different projects. So here you have a hybrid, which is the combination of the logs and banding. Then you have a fully inspectable panels with adjustable logs. Then you have a banding solution. Here you have also the banding, the stud bolts with epoxy bolt caps. So yeah, when we use the Hildy stud bolts, we also have to protect the bolts from outside with epoxy caps, we call it. So here you have a couple of cases. Tensioning profiles, when welding it's not allowed for a 1, 2, 3-sided PFP, for example, and the pop rivets, which is the cheapest fixing methods currently available. Application for removable PFP dry fit panels. So again, normally for PFP of the steel structure, you should consider a wet apply PFP. However, you might witness a unique situation that maybe removable PFP dry fit panels can be considered. So we would like to just give you the list of the potential situation based on our experience when those panels been utilized by our clients in the past. So for example, repairing damaged PFP on the steel structure, upgrading missing PFP on the steel structure. That could be also structurally inspected areas like bolted connections, sliding joints, beams, critical welding zones, critical low bearing nodes, floor boom connections, floor tower connections. Other also that could be the fabric maintenance, blockouts areas, when you face the situation, especially offshore conditions where wet apply PFP when the platform is in the full production. Yeah, there's a danger for a great danger for the people and machinery when you have a challenging conditions when it comes to the low temperature, poor access, HSE issue. and special cases like hang-off modules, tight schedules, other discipline interfaces. Yeah. One of our core applications, when we see there is a quite when the panels suits very well to the project, it's a retrofitting project, especially upgrading missing piece of the structure. So for example, when the modules or FPSO or platform are fabricated in the construction yard, for example, or they are construction on site when the project is on a stick build. Then just before the module loadout date or commissioning date, they discover, okay, this pipe rack hasn't been fireproof, and according to the drawings, it should be fireproofed. And that's a mistake done a long time ago, and they just discovered this. So there's enormous pressure on the schedule. The most probably pipe rack is fully painted, fully erected, fully equipped with equipment. So demobilizing all the equipment, removal of brand new corrosion system, providing the scaffolding, and make the surface treatment and repaint with a new painting and new PFP. That will cost a lot of money and a lot of labor, a lot of hassles. Different discipline trades will be, of course, impacted too with their own trade work disciplines. So our panels can give you significant advantages how to fix this in the very short period of time, and also with a cost-effective manner.
And it's my turn. Before we move on to the case studies, I would like to touch briefly on the work we do for testing and certification of our Benarx Epoxy series. For fire protection products like epoxy PFP and a removable epoxy PFP, there is a lot of investment in terms of time and money and activities to obtain the necessary testing and certificates. The most common fire types that we encounter are hydrocarbon fire curves like BS 476 or UL 1709. And jet fire according to ISO 22899. We also see a lot of high heat flux jet fire, which now is finally coming out with an recognized ISO standard, which is very good for the industry. Explosion testing. In the later years, we've done more of cryogenic testing, which I will come back to. And also some curiosities like fire water stream hose testing. We've tested our products up to 3.5 hours in the longest duration cases. And in order to sell in international markets, we also need to do third-party certification and verification of our testing. So in order to drive innovation, this is one of the key points which we focus. Doing more testing, reducing thicknesses, enhancing, getting better products, launching new technologies, and improving health and safety. Yeah. This is a brief snapshot from ongoing testing of a cryogenic test, which we were doing on a new version of our epoxy intumescent series. In this project, we are testing new Chartec technology in our system, and because of this, we are doing new cryogenic and jet fire testing. In this test, you see the LNG tanker truck here to the left. The specimen is subjected to quite high pressure liquid nitrogen jet impact for 60 hours, 60 minutes, I mean. And after the test, it's taken directly from the cryogenic test setup and erected into the jet fire chamber and subjected to jet fire temperature exposure at 1200 degrees Celsius. Not all systems can withstand this. We have tried different technologies, different products in the past. Some products crack and delaminate due to the extreme temperature shock. Some explode because liquid gas is trapped behind the PFP, and others fail integrity-wise in the fire. And this is these types of tests are key to ensure that our products lives up to their intended purpose when used in for example, LNG applications. Yeah. Here is a brief snapshot of an explosion test. This was an open module to capture the effects of drag forces as well. And you will see on the video soon to be shown here that we have test specimens fixed on the end of the container module here, which you also see a picture of in the bottom center picture here. And the intent of this type of testing is to verify that the product can actually retain integrity when being subjected to quite extreme explosion pressures generated from igniting gas sources in the process area. Typical pressures from this can range from 0.2, 0.3 up to 1.5 bar for a typical gas explosion scenario. And although you might think that 1 bar is not so much, I have 5 bar in my car tire or something, but on a 1 square meter area, 1 bar explosion pressure is equal to 10 tons of impact load. So you can imagine having 10 elephants on top of a square meter of your system. It's quite a harsh impact, and we have tested products previously which have not been up to the spec, and if your products first start to fail, you won't even find the debris. They will be out in the forest several hundred meters away due to the extreme pressures. These are forces that can bend solid steel beams. It's not to be underestimated. Yeah. Quick snapshot from a jet fire test. This was a structure one-sided panel application. You will see the panel fixed on the left picture here. A one-sided application with a I-beam on the wall in the center here, why you see this boxed coming around the center beam. Subjected to 2 hours of 350 or high heat flux jet fire testing, and on the picture on the right you can see a typical post-test picture how it looks. The chartec will be various degrees of eroded. The stainless steel core will typically be retained, and the object will remain hot for some period of time after the test is shut off. Yeah, a quick video from a standard jet fire test. This was from a epoxy box application actually. The test was run for 3 hours for standard jet fire exposure, and yeah, it's you don't feel the forces on your body before you witness a test like this. You see some pictures of a flame and you can kind of imagine, yeah, it's a big flame. But when you're present in these types of tests, the ground is shaking. You need double air protection due to the screaming noise, and it's a very chaotic and violent phenomenon to witness. In testing, it's important to try to capture the relevant geometries. As you all know, every process facility is different, every platform is different. It's not always possible to test every single geometry which you will encounter, especially for a custom product like this, which is often tailor-made for each application. We do a lot of testing for different shapes and geometries, different components like inspection hatch, drain plugs, different fastening methods, different sizes, steel massivities, in order to capture as broad span as possible of relevant geometries, test scenarios, components, etc. Here you see a typical cylindrical box to the left. We did an extra test with an inspection hatch here to the right side. On the bottom, you will see square-sized panels, which were fabricated for a cable tray application. And we also do structural tests as we shown in the pictures previous. Cryogenic testing, it's something that started to come up around 2016-17 with the new ISO 20088 being published after some time. As I mentioned briefly, this is a 3-part standard. You can do the jet exposure, the fog exposure, or the immersion type, where you actually immerse the panel system itself under liquid nitrogen. You expose it to 1 hour of liquid nitrogen, and then after the test, you go straight into jet fire or even explosion testing. And to put the amount of liquid gas used here into perspective, for one test like this, for a jet exposure, we use 7 tons of liquid nitrogen. It's almost the entire truck, which you saw in the picture previously. And you have to evacuate quite a big distance because there's so much nitrogen in the air that it's actually blocking out the oxygen. And everything is like a winter wonderland from the Disney Frost movie. So and then after the cloud clears up, you put this test specimen straight into the jet fire. You inspect that nothing is cracked, everything is still in place, no damage. You do the jet fire, and if you pass then you are kind of tested and verified against this combined scenario. The purpose of this, I think you can go to the next slide. The purpose of this CSP testing is actually to simulate the effect of liquid natural gas release onto the process area, which I will come back to a little bit later. Yeah, here you see an immersion test where we actually filled the entire panel system with a couple hundred liters of liquid nitrogen, and you can almost hear the top coat starting to making sounds when you making small cracking, sparkling sounds when you pour the liquid nitrogen due to the thermal expansion and all the joints moving a little bit and subtracting we have seen formulas and products which breaks clean off the steel because of this. So not every combination of material will withstand it. If the difference in thermal contraction between the substrate and the applied PFP is too big, it will just crack itself off due to the thermal movement of the two materials. It's always fun to test new standards, new improvements in the industry coming out. A couple of years ago, we tested a Firestream hose, which was it's called NFPA 290, and it's designed to actually challenge what happens to the ongoing performance of the system if it's subjected to high pressure water hose impact from, for example, firefighters or water cannons or deluge or etc. Because this can cause a lot of thermal shock to the system and also have an erosion effect on certain types of PFP. How the standard works, you do 20 minutes of jet fire, then you subject it to 10 minutes of water pressure, and then you follow on by doing a subsequent 20 minutes of jet fire testing to see that it can meet 50 minutes in total and provide the same duration to 400 degrees critical that it does originally. Here's what we call high heat flux jet fire testing. The only difference, the primary difference, I shall say, from a standard jet fire is actually the chamber is larger, so you generate a much larger flame inside a recirculation chamber, which makes the flame less transparent to heat radiation and as a consequence increases the heat load inside the fireball. There are some other differences as well, but that's primarily what you do. As a result of this, you get heat flux up to typically around 350 kilowatt per square meter. But bear in mind that both for standard jet fire test and for the high heat flux jet fire test, the heat flux will vary a lot. It's oscillating violently. It's not like a furnace test where you have a stable 1100 degrees throughout the test. In a jet fire, and especially in a high heat flux jet fire, you can have anything from 1000 degrees to 1450 degrees oscillating up and down. So it's really on the edge of what removable PFP systems can do. In some tests, you go beyond the point where steel starts to melt. So not every fastening component can do it, and it's really pushing the limits of both physically what's possible to generate in terms of heat in a fire, and also what's possible for a system to withstand. And it is vastly different from a standard jet fire. In a high heat flux, you can pass 2 hours for a system. You put it into a high heat flux, you can fail after 10 minutes because everything falls apart due to the high temperature. So it is quite different, and you can't interchange the two methods. You can state that 350 can cover a 250 because it's so much more severe, but you can never look at a 2 hour or 1 hour standard jet fire and say, yeah, it probably do half an hour or a little bit more of high heat flux. You need to test it to see. We do some testing on environmental exposure. So typical paint type top coat testing against weathering tests, the aging tests. And we also do some customized fire test for a hybrid system where we have our system as a repair system out existing or damaged PFP, as you see on the right here. Yeah, you can just move on. Here you see some detailed furnace testing of special fastening methods, bolted studs and tensioning profiles used for a 2- and 3-sided application. And we did this to verify that the fastening method would not be adversely affected by the wet applied PFP on the beam, and also by the heat ingress through the bolted connections. A tensioning profile is it's basically a steel rod which you can tighten to push out against the two flanges and get a secured connection anchor point to bolt on with the panels. Some curiosities here as well. We did some specialized test for cryogenic support to see how they would hold up. Cryogenic supports are made from various kinds of materials: pure foam, aerogels, cellular glass, etc. And we did a series of tests to actually verify to what degrees will the supports collapse, because some of these materials are not fireproof, and at what speed and with what heat ingress and what extra insulation did the insulated pipe supports provide in the test. The longest test there was up to 3 hours, and it gives an edge in terms of providing minimum thickness for the removable PFP to avoid doubling up, so to speak, on the thickness schemes. There's a lot of documentation works in our average projects. We deliver documentation based on clients' requirements. Some of the times we supply standard documents and that's enough. Other times, especially for big new build projects, the client often requires quite extensive documentation work. So we are able to follow whatever documentation scheme we are faced with. Sometimes there is no need for project-specific testing. Otherwise, we need to do project R&D, project testing to to tick off the right quality marks of the projects. And we supply both customized and standard documentation packets. It can be 5 pages, it can be 50,000 pages. It depends completely on the scope and the client specification. Briefly, going back to the explosion part, we also do both explosion simulations and also thermal simulations for special applications. You can never test every single geometry that you have in a project. You have to test a representative range, and in order to address and verify that geometry of a certain project is not generating challenges or going or making geometries, areas, sizes, etc., which is not up to the task. We do customized simulations for many projects to verify that we address and we consider the relevant geometries in a how to say good manner.
All right. So one of the first question that we've been asked by a project, what's our delivery time? So of course that's dependent on the many factors. For example, what's the volume that you need the panels for relevant application? Is it custom built panel or is it standardized panel? What's the PFP thickness? What's your spec? However, I would say the production lead time itself is from 4 weeks and upwards, depending on the volume. So if you have, for example, 500 square meters of the panels, we can manufacture this within 6-7 weeks from one of our factory. We have factories in Poland and in Thailand. Both of them are ISO certified and are also strategically located close to the airport and the seaport. Of course, we would like to also show you how we do those projects, how we run it. So first of all, we have to define what's the design methodology for our panels. So that can be designed based on the client 3D model, the reliable 3D model, or based on the 3D scans. We can also use client 3D scans if the file is compatible with our software. Then we can design those panels also based on the combination of GE drawings with side pictures and maybe some simple side measurements. And we also witnessed a couple of projects that we designed our products based on the point of the clouds. So they mobilized the third-party scanning company who scanned the entire plan, and they generate this point of the clouds, and we can utilize basically that. So we run it like this. We define the design methodology, for example, field measurement to send one of our surveyor to the facility to do the site measurements. Then we create the drawings, we calculate the PFP thickness. In the meantime, we start preparing our documentation. Then once the drawings are approved by a client, then we move to the factory. The factory is producing this. Then we pack it, ship to the projects. And then normally projects prefer to use our own local labor to install our panels. That's not a problem for us, and our panels are easy to install. But of course, if we are requested, we can also supply our labor. Very often when the client use own local labor, we can supply also one or two field supervisors who provide training and supervise ongoing installation works. Again, just a few snapshots about our design methodologies. So we can design our panels based on like a 3D model that we receive from the client. We can do the 3D scanning either with our scanner, or maybe client has their own scanner and they can scan it this by themselves. If the object is larger, we can split these scans per object and then connect both scans together in our software. Then this example of the point of the clouds for one of the project in Australia that we utilized to design the Benarx Epoxy Panels to the repair damaged PFP. Or we can basically send our field surveyor to do the on-site measurements, and he will create the manufacturing drawings for our panels. So we have several options, and we will define the best methodology together with project after a short communication and questionnaire.
Yeah, as Damien briefly mentioned, we do a lot of different methods in terms of design and execution model. We work a lot with the 3D and 2D drawing and 3D models from the client side. Most commonly, we use either scans or manual surveys as the two primary methods, but we have also done a number of projects where we rely completely on either shop drawings or 3D models, like you see on the left here. Typically, the Naviswork model, like you see on the left, doesn't capture everything to the complete accuracy. So when we do this, it's often as a preliminary scan, and then the client or our on-site surveyor will go out and check the model afterwards and make the necessary corrections. Yep.
Yes.
Yeah.
A few words about our services. So we can provide those services based on the agreement with the clients, what he needs, what the project needs, what's the best, what's the cost impact, what's the schedule impact, etc., etc. However, field measurements, that's typically we rely based on sending one of our surveyor. He will measure all the structure members. He will create the manufacturing drawing. He will discuss with the client the access requirements like scaffolding, basket, crane, rope access when it comes to the offshore, discuss all the complexities. When it comes to the installation, we can of course supply our labor, but we see this many often project wants to use local labor, so they can easily install it. We don't have any specific requirements when it comes to the discipline. However, of course, if the workers work previously with a PFP or insulation industry disciplines, excuse me, then of course that's a small benefit. It's very easy for them to learn very quickly how to install our panels. But this can be also handled like for example by mechanical fitters. One of the very often questions we got, okay, what's the installation time and its performance per hour, how many linear meters of the panels or how many square meters of the panels the external worker can apply on the structure. So based for the standard like not complex items, I would say we can achieve 1.5 linear meters per hour per installer. For complex items, that will be most probably around 1 linear meter per hour per installer. And of course, if the project used own labor, very often they order our field supervisor. So supervisor will provide on-site training before the project startup. He will supervise ongoing installation work and then ensure the installation will be done according to the installation procedures and according to relevant fire certificate, which maintain the product warranty. And of course, when some boxes will clash or don't fit by some reasons, or project needs to rebuild some panels on site, then our supervisor will be in charge of those modifications. This is the example of installation tools accessories. So when installing our panels, just basic power tools are enough. It's very easy to outsource them locally before the installation. We will ask the questions to the project. Will you source the installation tools by yourself, or do we have to deliver this? So majority of the projects, they prefer to sort this locally, since the list it's not long and it's not very complicated, especially to the power tools. So of course we will submit this list to the project before we ship the panels to the facility. Yeah, also some small. We will send also the small modification package, we call it. among all the panels that will be fitted on the steel structure members, we sent you a couple of, we call it flat packs panel, or just flat panels with the same thickness as a normal panels. This is when you have to do those panels for some modifications, because some panels they need to be flattening, or they need to create some bypass or any other similar situations. Maybe some panels they need to be rebuilt on site, so both workers and our supervisor can use these panels to rebuild the panels on site. So for your information, our standard weight restriction per panel is 25 kg per panel. Of course, if you have a lower weight restriction, we can make the panel smaller, and it will be in full compliance with your requirements. Yeah, especially COVID. It wasn't possible to go to the project on site. That was technically impossible, and no one will pay a lot of money just to have one of our personnel sitting 3-4 weeks in the hotel just for a quarantine. But we got some projects before the COVID, and we got some projects during the COVID, and we have to deliver our commitments. So we developed the remote training, which is now standard procedures for training external installers. So this video shown on the right side, it shows all potential modification in our products. So by watching this, your installer can easily replicate those procedures in the panels, and modify the panels according in order to fit nicely. We also see some small demand for remote training or remote supervision. If you use our panels and you install by yourself and you need remote supervision, by some reasons, if you have faced some issue, send us the email, send us the photo, send us maybe short video, send us the short description of the issue, and we'll review it, and we will come back to you most probably in the same day or the next day, the latest. All right, we move forward to the probably the most interesting part, which is the case studies. So we prepare for you quite a lot of case studies, just to show you our experience, what's the advantages of our solutions. But from a case study number one, that was a job done for one of the offshore platform in Norway. The platform witnessed damaged cementitious PFP on the structure, which you can see on the photo. And then we supply our panels as a wrap-up system. So we wrap up the existing damaged PFP with our Benarx epoxy panels all around. So that save a lot of money and time for a platform owner, because they don't have to remove existing PFP. They don't have to blast it off once again. They don't have to repaint it. They don't have to reapply the new PFP by the wet application methods. So here you have also some other pictures when we applied for the same project, some Benarx epoxy panels for the columns, for circular hollow sections, for the steel structure members. So some of them they've been done in the quite congested areas too. Here you have an example of inspection hatches on the bottom section of the panel. Another case study is from Kazakhstan. The goal, the requirements was upgrading missing P on the pipe rack. So before the commissioning, they discovered where the pipe rack being fabricated in Middle East. The fabricator forgot to apply the PFP on the pipe rack. So the pipe rack was already delivered to the site. The pipe rack was fully erected, painted, and equipped with all the equipment around. And they just discovered this. So, and the planned work was actually for the winter season. And also the location of the main pipe rack was close to the sea fastening zone. And that was the great danger for the people and machinery, as well as in this area in the sea, they are living very special type of the fish. which was fully protected by a local government. And so the agency really didn't like the way forward with a wet applied PFP. So due to these reasons, they chose our panels to be used. Yeah, here you have an example with a three-sided PFP, how we do this, and that was particularly used for this project. So the panel length, as I said earlier, is a 1000 millimeters, and both panels are connected together with a splicer, we call it. It's just prefabricated connecting elements. On the joints, you see the tensioning bands as a fixing methods, while we use the logs. And the center to center, it's normally 150 millimeters. Here you have example with four-sided PFP for our panels. Yeah, we just go around. This is example from photo for four-sided panels from our factory. So yeah, we have also this solution. Here we have a snapshot from the project when pipe rack, how the pipe rack looks like before the application of our panels and after. So for this particular project, we supplied over 2,000 square meters of our panels. They have to remove only 5 up to 10% of the existing cable tray from the structure, just to give us the access to relevant components, just to let us to install those panels on the structure. It's quite well visible on this photo. Then you have this example with a PFP under grating with our panels. Normally, when apply PFP, it's not allowed to use beater, so we use this. So top flange of the beams, it's not fireproofed. Our panels is designed for a three-sided scenario and equipped with a logs. We also fireproofed the firewall of the cooling towers. That's why you have these vertical panels. Yeah. Another case study is from FPSO in Angola. That was FPSO. So of course, since this FPSO, so vessel is floating. Since it's floating, so on the main pipe rack, these critical welds and load-bearing nodes that are exposed for a lot of stressing, twisting, bending, etc. And then based on the fire risk analysis, they identify those zones as a critical, and they want to have a removable PFP over there. For remaining areas of the pipe rack, they just use wet apply PFP. So that's one of the main reasons why they use our panels. As you can see on the photo, here, for example, the panels, it's overlap on the wet apply PFP, providing the necessary code back. So this is the same principle, like you protect the PFP on the secondary members. The code back, standard code back length, it's a 450 mem each side. Another case study, it's from a floating offshore platform in Gulf of Mexico in the United States. The reason why they identified these critical welds and on the upper hull structure, so they want to have an easy access for a quick inspection. So that was the scope of the work. Yes, Adrian?
Yeah, and this was a special job. It was for fire protection and basically refurbishing the existing old cementitious PFP on the inside of the platform legs on a top side in Norway. The existing cementitious was cracking and falling off, and due to the limited access and difficulty in working in this narrow environment and the time saving on site, they opted for a Benarx panel solution. In this, there were 4 similar sections like this, and they saw that with the amount of hours they would spend on removing the old PFP, refurbishing the coating system, the primer, the PFP, top coating, the difficulty and HSE challenges of working in enclosed and confined spaces. They could save a lot of POB, personnel on board, at the same time as reducing the execution time and improving worker health and safety to avoid working with chemicals in this narrow and confined environment. They designed with inspection hatches, as you see on the pictures here, on the central area, so that they could open up in inspection from time to time in their inspection program, and actually keep track of the state and of corrosion and if anything was developing below the system. Yeah.
Yes, another case study is to repair damage low weight cementitious PFP on the living quarters. So one of the end user discovered this issue, and since living quarters, that's the place when the people are resting in the offshore platforms, and general offshore platforms are very quite complex projects with not so much space between different areas. So since they are not so much far away from a processing area, there's a lot of noise, vibration going around. So first of all, they want to, of course, repair damage PFP, and the second demand, they want to ensure that the new PFP will reduce the noise around. I think it was around 10 decibels they have expectations, and of course they have a strong pressure to supply the solutions, the new solutions. So the way how we propose the solution and how we did the job, we design and install the frame around the living quarters by the sectional steel, which was screwed to the existing wall on the top of the defected cementitious PFP. And then we used our panels to install on the sectional steel directly. We used the fixing methods pop rivets and the sectional steel fastened to the wall as a support for the Benarx epoxy panels. So this is how we did this project. Another case study was done. This job was done in Kazakhstan 3 years ago, more or less. The goal was a little bit similar, like we did for the projects with orange painted panels, shown a few slides earlier. So that was to upgrade missing P of the steel structure. They forgot to apply PFP in the fabricator yard. They discovered this on site. Was fully erected, fully painted, fully equipped. In Kazakhstan in winter time you have a -30. In the summer you have a +30. So and the plan, according to original plan, the work was planned during the winter time. So how we did it, we sent the surveyor who measured all the steel members. We've got the drawings, so we have to supply panels for nearly entire modules, and our surveyor then designed our panels very nicely in the SketchUp software. So you can see this video how we designed those panels based on the drawings. So it's not for us very often that we got the job that we have to fireproof nearly entire module. The client didn't want to go with a wet apply PFP because of the difficult conditions for the wet apply, since that was planned for the winter time. They have to blast it off and remove existing coating, which is very time consuming and very costly. They want to use the dry fit panels. So a couple of pictures from that projects. We supplied for all kind of the structure elements, columns, circular hollow section, cross-sectional bracing, concrete pedestal. We use different fixing methods for different locations. That was really a good, successful project for us and for the client. We've got very good feedback in the end of the day. And here you have also a couple of other pictures. We also supply the solutions for a PFP under the grating. In total we supply, I think, 7 full trucks of our panels, seven trucks of our panels. And for installation crew, I think they utilize around about 19 up to 20 installation workers, together with one of our supervisor who trained them out before the project started up. Another case study is from Indonesia. In my opinion, one of the most toughest jobs we made for the structural inspected area so far. And this is due to the several reasons. First of all, the project is located in the earthquake zone. The facility is exposed for the tropic rainfalls. Temperature is quite high there, high humidity, exposure. The structure is still sliding joints being installed in the very congested areas. There's a wet-applied PFP over there, and since this is the sliding joints that are moved in two directions, it's nicely visible on this graphic. The movement is up to 35 millimeters, and this is to tackle the potential earthquake movements. So here you have a couple of photos from these projects. We overlap with our panels on the connecting wet applied PFP with this prefabricated coat back. Here you have also example when we design the inspection hatches as per the project preferences. The cable tray, they can be easily laid down on the top of our panels. They can easily withstand those weights. And there were some locations where very, very little space. A couple of other projects, a couple of other pictures from the same projects. So the lack of space, was a main issue. Since the project has been located in the rainfall conditions with a high humidity, they have a lot of concern about the corrosion under fireproofing or corrosion under insulation. So we've got a lot of long list of the question from the project before we convince them to use our solutions. But yes, we managed to design to be fully compliant with the specification and with all the movements coming out from the sliding saddles, and we installed and delivered the panels according to the schedule. Another case study is from one LNG facility in Russia. That was we supplied this because the existing PFP cracked, as you can see here on the picture. So that was severe cracks, before we repaired the entire structure, the client was not 100% sure if our solution is suitable. So we did a lot of internal testing, like a CSP testing. We went also to the laboratory to get the combination of the CSP and PFP testing, which Adrian talked a little bit a couple of minutes ago in the previous slides. And we did the trial fitting job on site. So we delivered like around about 100 square meters of the panels. And then the project wanted to wait for 1 year to see what's the condition of our panels after 1 year, if it doesn't fail or fallen off or cracked in the worst case scenario. And after that 1 year, they inspect our panels. It looks good in the same conditions once they've been installed, and we've got the entire job. So we supplied nearly 4,000 square meters of the panels to repair this cracked PFP. So installation was also planned during the winter, but we are completely not weather dependent. They've been installed by local mechanical fitters who never worked in the PFP or insulation before. We sent only 2 supervisors to train them and to supervise the ongoing installation work. As you can see here on this picture, the cable tray are laid down or on the panel surface, and they won't crack too due to this weight. So this is very robust and durable system. This is a quite fresh project from Australia, from one of the petrochemical facility located in Australia. They've witnessed the crack of one of the lightweight cementitious PFP on the steel structure. We already designed and supplied those panels quite a long time ago, but they haven't been installed due to some delays from previous, some other installation units or some previous discipline delays. They will be installed most probably in the mid of the Q1 next year, most probably around February, March next year. But we designed those panels based on the clouds, based on the point of the clouds. So we utilized this file as a design methods. We never been there, and we did the design fully remotely. And the project had a few challenges, like is shown here on this drawing. For example, there was too little space between the cable and our panel, despite our panels are very, very slim. So we have to do some local flattenings in our panel to accommodate this small issue. And also here you have a no clearance between the cable trays and the foundation. So we fireproofed entire foundation, as you can see here, while the cable tray penetrating the panels through. And these minor gaps will be sealed by intumescent tape, which was shown at the beginning of this presentation. So this is how we're going to do it. The goal for the project is to use own local installers with one of our supervisors. So of course, we are excited to see a nice photo from the project once the panels are fully installed, and we keep fingers crossed the client will be very, very happy. Yes, Adrian?
Thank you, Damien. This was also a quite recent job from a large petrochemical plant in Norway, a land facility. As an old plant, they also have the challenge of degrading PFP and both cementitious and other types. And to minimize the amount of work on site, we had a discussion and agreed that we should do epoxy panels for this job. They installed the panels, and on the central two pictures here, you will see there is a kind of a plank of epoxy going on the upper edge, and this is actually what Damien talked about earlier on the webinar, these splice bars or modification kits that we can supply not only the customized geometries and prefabricated solution, but also standardized epoxy panel material in terms of angles, plates, planks, latch connection, which allows the workers on site to make minor modifications for the small variances or intolerances to the equipment. So if they have some gaps they need to fill, they need to overlap some missing components, they need to construct some box for a nodal connection or something on site, they can use this standardized material to be self-reliant, so to speak, on site, and not stop the progress because they're waiting for a special box, let's say. This is from a top side in the North Sea in Norway. Similar situation, old degrading PFP, some corrosion, very limited space, as you can see from the picture. And with the top sides, and especially offshore, it's also always a challenge that they have limited space for personnel on board. POB, personnel on board, is always a key talking point, which the client is concerned about. They simply do not have space for all the people needed to do everything that should be done. So when we can move labor-intensive work like sandblasting, paint work, habitats, reliability on weather, move all of this into a controlled facility environment like we have in our factory, we can save a lot of hours and personnel on board, and help the client with a how to say, a personnel light solution to the problem. Of course, a job like this could easily be done by wet applied, but you will need the scaffolding, you will need the pumps, the equipment, you need a habitats to keep hot air and a good environment around the application of the PFP, of the painting. You need the sandblasting. If the sandblasting generates too much noise, then maybe other disciplines cannot work in the area. There can be impact to other disciplines. There's all sorts of negative effects of having too much labor tasks on site. Similar job like this, nodal connection areas. These are often key inspection points, key areas which the clients want to have good monitoring of, to see that no cracks are development in the critical wells, to see that the bolts are tight, to perform checks after tightening of the bolts. And they often congested with other equipment, as you maybe see on the bottom left picture and bottom center picture. There's a lot of nearby objects and confined space here, which means that it's not very easy to reach the object with a wet applied approach, let's say. So special areas like this with limited space and key need for inspection is a very good fit for nodal epoxy boxes.
Yeah, then another case study is also from Australia, for this time for a gas compression station. Maybe this is not structure, but this is more like for a piping, but it's quite interesting. So they discover the damaged PFP with a corrosion on the 40H pipe with a T-stick, connecting T-stick. So project decided to remove the current coating with a wrapping, and they require the removable PFP since this is most probably very critical welds. So this is the section of our Benarx epoxy pipes, which is just same like a panel, but it's in tubular shape. You see, this is the very quite complex fixing method, since we use the bending and the locks. But yes, this is the example how we make this job. Another case study comes from a petrochemical facility in Korea. So end user witnessed the damaged PFP on the vessel skirts on the bottom. So that PFP has been deteriorated over the years, and they decided to use our panels to repair this damaged PFP with our panels. So of course we have to use the tensioning frame around the vessel skirt. So normally, this a little bit similar, like you use the supporting rings when you apply the mineral wool for the vertical vessel, for example. So we use the same supporting rings, and then we apply the panels to those rings, and we equip the panels between the segments with adjustable locks, so they can have easy access to the metallic substrate. Yeah, Adrian, tunnel from Sweden.
Yes.
Sweden.
Yes. We of course operate primarily in the oil and gas sector, but we also from time to time encounter relevant jobs and challenges in other industry. This job was for an infrastructure maintenance project in Sweden. The case was they had a civilian car tunnel with a bridge on top, and they discovered that due to degrading cement on the cement beams holding the bridge ups, they enclosed this cementitious beams in a steel caisson to repair the concrete, to use the steel as a mold. And then another challenge came up, is that the steel used for this purpose is not fireproofed. So it meant that they discovered that with this new steel caisson around the concrete beam, they would no longer be able to. The beam would not necessarily retain integrity in terms of fire from cars or heavy transport or electric car, battery fire, stuff like that. It could pose the risk of actually collapsing the bridge above. And as a result of this, we were approached by clients to see if we can find a solution. They were in discussions with a local company to apply wet applied PFP for this purpose. But as you can see, there was very limited space above these beams. There was only a few centimeters, which you can see on a few of the pictures, in clearance above. and it would be practically impossible to apply in a proficient manner the wet applied PFP in this small area. Due to this, we managed to convince the client that we could do a panel solution here, and that would also have the extra benefit of shortening the application time and the time they needed to shut down the tunnel for civilian traffic. So we were able to go up with a simple how to say, lifting basket type equipment, and in our installers just installed standard C-shaped panels going along the beam, and this was fastened with both pop rivets and also bands, as you see, as a double security measure to in case the pop rivets would have any problems over the next 100 years. The execution went very well. The tunnel was up and going in quite a short time, and yeah, it's always good to move beyond the traditional oil and gas applications which we're usually working in.
Yes, I agree, Adrian. All right, another case study, this time structure inspected areas, in particular, for example, bolted connections. So here we have example actually from two projects. One project is from onshore gas processing facility in Norway when they want to supply the removable PFP on the bolted connection. Why? Because as per inspection program, they have to do the tensioning checks in those bolts from time to time. So that's why they use our boxes or panels on this particular case. Another case was for structure inspected members on one of the offshore platform in Canada. They identified those critical steel members, and they want to use our panels. So we sent them, we rent them one of our 3D scanner. We provided the training. So platform works, they provide physical 3D scanning. They send us 3D scans through email, and then based on that, with simple side photos and some simple side measurements according to our instruction, we designed our panels there. We shipped, and they managed to install by themselves. So here you have a couple of pictures from these projects. Another case study, this time flood boom connections. From time to time, we witness those cases. Actually, there are three separate projects. Project number one, offshore platform Norway. The flood boom connections, flood itself is a very critical equipment, allowing the platforms to burn the excessive amount of the hydrocarbons during the emergency events. So these flood boom connections, of course, they're critical welds, and without the PFP, in the worst case scenario, the flare itself can collapse. So they want to have a removable PFP. So this is the pictures. The another case is for a flood stack connections and structural inspect areas. So the same case like from the project from Norway, but this both comes from one offshore platform in UK, also flood boom connections. Just to have a removable PFP and have easy access to this. And we also protect some flood boom connections below the deck. So here you have pictures. It's a very, very congested area over there with some wet applied PFP around. And the last project is also from Norway, completely other platform for one of the oil and gas major. We supply the panels for the flare tower connections. So those flare connections, the project identify critical welds, and that's why they want to have a removable PFP, because from time to time they want to have access. Another case study, also structurally inspected areas. So that's from one of floating offshore vessel in Norway. You have three different scopes for the structure applications. One is flare stock connections. So similar as a previous slide. Critical welding zones and above and below the deck. So here you have example of of the critical welding zones above the deck and below the deck for the same location. And then you have also flare stack bottom and its connection either below or above the deck. So this has to be inspected since they have a critical welds and they want to have access to this. So when apply PFP is not the best solutions for this particular case, because if they would apply, then they have to constantly remove the existing PFP in order to have access to the substrate. One of the last case studies, this one it's from UK offshore platform. We supply the panels for supporting legs. Our design team, they have to be careful because first of all, these supporting legs were exposed for a splash zone, and that's very concern when it comes to the corrosion. And PFP has to withstand all these wave loads, wind offshore, very corrosive environment. So that's not the easy for any PFP material itself. However, we also did some mechanical calculation that our box and the fasteners are able to withstand external forces. We managed to design and supply, and the panels being installed by external installers through rope access techniques. Another case is for a flare boom connection for another platform in Norway. So those flare tower connections are having removable PFP to have access to those critical welds inside. And the last case study, we call it special cases. There are two projects. One is offshore in Norway for hangout modules. So yes, for these hangouts which needs the PFP are caused by installation of the new module so to the main platform. So during the installation, the hangoff nodes could not have a PFP. So main reasons: the inspection of the welds of the later stage, difficult access to perform the weld apply PFP. Avoid the process of the surface treatment. Avoid any weather limitations since this is North Sea offshore. So weather is unexpected over there and very congested area. So that's why they use removable PFP over there. And then on the project number 2 from FPSO, this explosion wall, I mean, they used existing explosion wall, but they discovered some mistake or whatsoever, and they want to make this explosion wall a few meters higher. So this new explosion wall modules being fabricated onshore, and they want to avoid the wet apply PFP offshore in specific. So those new connections between those two explosion walls, they need to be removable PFP for easy access for inspection. Sorry, that's actually that's the last case study. So this is the panels for a crane pedestal. Crane pedestal, it's one of the critical equipment offshore since it's lifting all the guards from platform to the bows and opposite. And of course, the bottom of the crane, when you have these weldings, are critical from a structural point of view. So we supply the removable PFP around the crane pedestal, above and below the deck. Unfortunately, I couldn't find the pictures better than this, but we got some video showing the panels below the deck for crane pedestal. So it should be quite well visible. So you see, there's very congested area, very little space. And another, it's for utility south stair tower below the deck. We supply these solutions for easy inspection to the substrate. unfortunately, it's not easy to get the pictures from the end user, what's the conditions of our panels or boxes after several years in use. We don't have so many pictures showing showing the panels after a few years in the service. However, we've got for our boxes for a process equipment. So since this is exactly the same material, the main difference is just geometry and the applications. We would like to show you how our solutions look like after several years in use. So one, it's some boxes for emergency shutdown valve for offshore platform in UK after 7 years. Then you have another offshore platform in UK showing the boxes on the actuator after 8 years. So you see the box is fully exposed for the UV, rain, snow, all the conditions around the chemicals containment. You see entire platform is a brown, while our box looks more or less in the white color. This brown color, it's coming out from a sea salt fog from a North Sea. So simple water jetting will fix this small issue. And this is from Australia, from Peruta FLNG after 5 years. Yeah, here we have a picture showing the boxes after 10 years. This is from one onshore gas processing facility in UK. We supply over 1,000 boxes for various applications. So they've been installed in 2007 and they've been inspected in 2017, showing this is basically industry evidence how our boxes looks after 10 years. So we are not telling you that the box looks like a new from factory, but taking into account 4 weather different zones. A few times most probably removed and reinstalled by external installers. Fully exposed for the sun, UV, rain, chemical containment. Most probably they've been maybe brutally treated by site maintenance. And we think they're looking pretty okay after 10 years exposure. And the last photo, we've got actually one picture of our panel after 1 year. That's for one LNG liquefaction facility in Russia. So when they did some trial testing to supply 100 square meters of our panels and to see how the panel will look like after 1 year. So we've got this photo. So now these panels are there for the last 7 years. LNG in Norway. After the box looks after 10 years. For your information, this is not the rust on our box surface. This is the leakage from the gearbox. So they've been installed. I think we supply more or less 2,000 boxes for various applications. So really large job for us. And so that's the conditions. And this is the pipe shall install the pipe on the piping exactly from the same project. We've got this photo actually last year, and it shows the conditions of the installation after 70 years. So of course here you have a little bit dirty pipe shell because that's most probably some hydraulic oil or whatsoever, some chemical. But this simple water jetting will fix this, and the box is fully functional, and in case of the fire, it will be reacting as intended. We would like to show you quickly installation mock-up video that we perform in our factory. So have a look.
The video shows the installation of structure panels. Our previous factory manager here at Kent is demonstrating the assembly. These panels are fitted with spacers inside, so they get a good support against the steel beam here. And as you can see, in this case, the panels are fastened with adjustable eccentric removable locks. You will see there is a overlap connection on the edge, so each panel is overlapping slightly with the next one. In terms of assembly on vertical beams, we placed the male joint, so to speak, on the bottom. The female joint comes on top on the next one, and this is to ensure water shedding purposes. There is a timer here on top of the beam to the right, showing the real time, as this is a fast forward video.
Now corner of the steel structure.
It's important to note that the system is quite tough and durable. You can bash this into place. You can use a crowbar, a hammer, a rubber hammer, heavy strapping bands, whatever you need. You can treat it quite roughly to get it into place, and you don't have to worry about breaking or stepping damage, impact damage. If you lose the product to the floor or to the ground, it will not take any significant damage, and it can take a lot of manhandling. Now we see the T-piece. In some projects, we actually decide to fabricate the T-boxes on site. In this case, it's prefabricated as a custom T-piece. But we can also make overlapping made on site based on panels boxes for this as well. And you can have a third option where you actually just take two straight pieces, make a cutout in the smaller one, and just join them with a latch connection. So there's lots of different options how you terminate details like this. It depends on what's most practical for the project, what's the lowest risk, what's the easiest for the guys on site, what's quickest, what's cheapest, etc. So
I think it's worth to mention that this installation is like a Lego bricks principle. You just follow the drawings, you take the relevant part and you put on the steel member.
And when we are packing this, we are typically marking the products with a series number, and you will get detailed drawings showing where to start. Are you starting from the top or the bottom, from the side? Which way are you building this up, and in which order? And you will also find these markings which you see on the drawing on the packaging materials. So it's easy to find and identify the correct components when you are unpacking this on site.
Yeah, and I think job is completed.
Yeah, there's one part missing after the assembly. He will install the safety pins. You have these security pins to ensure that the locks remain closed. But yeah.
Yeah, this is our complete track record list for our Benarx Epoxy Panels. So of course, we show most of those projects in the previous case study section. Yeah, we supply this to different projects all around the world: Norway, UK, Kazakhstan, Russia, Australia, South Korea, Canada, States. So yeah, we definitely there. We are supplying this to the different weather conditions. So our panels are functional as intended until today. Short snapshot of our track records list. So for a floating vessels like FPSO, FLNG, floating offshore platform. So yeah, we definitely on this market. Majority of those track records are referred to the process equipment scope of the work, like emergency shutdown valves, flanges, manholes, etc. So yeah, we are on this market too for a long time. Yeah, our industry offshore platforms as examples. That's our bread and butter since we've been founded. We have much more, but this is just example of reference. So we supply our solutions to platforms all around the world. And the same basically for a downstream. I think we have more than 50 track records all around the world to supply our solutions for various projects for various scope of the work. So we are on this market too. So one of the last slides. So we just the wrap up comes to the end, and we would like to just highlight brief summary of the advantages of the dry fix panels. Of course, that depends on if we are talking about the repairing damaged PFP or upgrading missing PFP or the structurally inspected areas. However, when it comes to the repairing or upgrading missing PFP on the structure, no need for the sandblasting and priming of the steel, no need for habitats, weather covers, heating devices when you plan your application during the winter. You don't need so much scaffolding. Our system is fully compatible with any corrosion protection system, including thermal spray aluminum. Our system can be installed on top of the damaged PFP. No need for removal. Not weather dependent. Quick installation, and the system is fully removable and truly reusable. Yeah, we can supply standardized or custom built panels. We can design the panels to allow the object underneath to be movable. It's fully robust and very durable system, which shown in the previous case study before. Very well tested, very well certified by a third-party classification society. It's a low weight, slim design, slim PFP thickness. Expected lifetime, it's at plus 20 years or more based on the photo from a previous project after several years. You don't need any hot works on site, no solvent on site, less equipment on site. It's very little waste. And of course, in the end, it mitigates the corrosion under insulation and corrosion under fireproofing. Yes, so thank you very much being with us until the end. Hope you like the webinar. Before we finish, we would like to just inform you that if you have any questions refers to this webinar or and you would like to, don't hesitate to send us the email with those questions. If you are facing similar scope of the work that we present earlier and you have some questions regarding what's the lead time for our system, what's the budgetary price or whatsoever, don't hesitate to send us the request. We will review it and we'll get back to you. Please, as a last thing, please follow us on our LinkedIn channel. Here you have a QR code both to our Benarx LinkedIn and also to my private LinkedIn that we can get in touch, and you can we regularly post trying to post nice technical stuff about the removable passive fire protection, and yeah, hope you like the content. So in general, thank you very much for the time being with us, and I wish you have a good day.
Thank you.